Hello everybody. So this is Prabhat here and I am your coach for your all your requirements related to finance, personal finance, data science, Python and all those latest topics which is booming in the market like chat GPT and all those things which is known for snatching individuals jobs because individuals are less competitive compared to machine. So that's how I represent your coach in all these dimensions, in all these fields, and uh, I have studied finance basically from different places, and I am a finance expert. But over a period of years, while working in industry for the last 15 years, I have equipped myself with the knowledge in the data science and artificial intelligence in such a way that I can help you guide how to secure your job also when it comes to data science and artificial intelligence. How chat GPT is taking away jobs in India and abroad and how to get over that. So this is all on the first place, but here I am not for explaining all those stuff and explaining all those things. So what I am here for, I am going to solve a problem, a miracle, a thing that kept me in doubt for over 5 6 years in past, and I had no clues. I searched all over the across everywhere on the internet, but I did not get a solution to that. And now I have finally come up with a solution to that, and that is there in some of the discussions that I'm going to talk about you about complex number. So you will learn this thing about complex number. You might never heard about that in complex number, that we talk about cube root of negative unity. So this thing was quite puzzling to me because cube root of square root of negative unity used to be I. We always bothered like what could be cube root of negative unity, what could be fifth root of negative unity, what could be seventh root of negative unity. All these things was quite puzzling, so we had no clear ideas. Now in today's session we will experience how this all these things concepts will be clear, and you will be able to say that all the roots, be it cube root, fifth root, fourth root, 10th root, 12th root, 13th root, all those roots will be ultimately expressed in terms of a complex number with real root, with real part of and the imaginary part as just like any complex number. So that is what I am going to show you today, and it is very well embedded in the NumPy library and the complex number concept of our Python, where we can really experience it very well, and we can do the calculation within second, and we can get all those roots immediately. So let us see and dive deep into the problem. Okay, so here we have, so now we are jumping directly onto the problem, and you will be seeing that here we have NumPy operations on complex numbers. So in this problem you can see that defining the problem, finding cube root of negative unity, you can see here. So this is our exercise, and in this exercise we are first looking at x. This x we have to identify, and this x is nothing minus 1 raised to the power 1 by 3. So we are finding cube root on minus 1. Now the next step that we do here is we make the power minus 1 3 move on the other side, then it becomes x raised to the power 3 equals minus 1. So both the statements are almost same, and now we go to the next level where we get x raised to the power 3 plus 1 equals 0. So this way we get a equation that need to be solved. So x cube plus 1 equal to 0 we have to solve. So we are creating the factors and equating to 0, and we get x plus 1 can be taken as a common from x cube plus 1, and the remaining factors can be written as x square minus x plus 1. So that way we get two factors, and this two factors can be equals to 0. Now getting all the roots is the next exercise, and x plus 1 is equal to 0. So x is equal to minus 1 is one of the roots definitely, and the other roots can be taken as from the quadratic equation that we got in hand. X square
minus x plus 1. So from this equation we can get the required quadratic roots, and we got 0.5 plus 0.866i and 0.5 minus 0.866i. So two quadratic roots we got, additional quadratic roots we got here. Now we have got NumPy calculations. So with the NumPy calculations, we are going to show all these findings here. So until now, I was thinking that x equals minus 1 to whole to the power 1 by 3 can be treated as a another complex number, like I is there, so we can have k or w or whatever, a new imaginary number can be created for that. But this is not the right choice. We cannot do that. We simply have three different choices here. This number can be equated to minus 1, or it can be this one number, or this 0.5 minus 0.866 as third number. So we have choice for this quadratic equation. So that is how we have got some solutions for this equation, right? So no need to worry about that. Even if we'll have minus 1 raised to the power 1 by 5 or 1 by 7 or 1 by 13, anything, we can have some solution for this equation, and we can find the real solutions for them. So those solutions are now we are going to see in terms of NumPy operation. So NumPy, we are creating an array. So this array I have created, this array you can see ARR1, and this is having complex number with real parts only, minus 3, minus 2, minus 1, 0, 1, 2 and 3. So all are real numbers only. I'm not involving complex numbers with a imaginary part. So all are real numbers, right, from ranging from minus 3 to plus 3. Okay, now we are just giving all these things in our taking a square root. So now we are taking a square roots and we are printing all the square roots. So we see that minus 3 plus 0 is having a square root, like you can see 1.732. This is the root 3 is the square root here. So if minus 3 is the number, then a square root is my 1.732j. So this way, this is imaginary part. Similarly, if we have minus 2 as real number, then its root will be 1.414 as imaginary number. Then here real numbers are all you see can be equal to 0. You can see all these real numbers are equal to 0 because they are having very low powers, powers minus 16, minus 17, minus 17. That's mean equivalent to 0 only. Okay, so that's I assume as 0. Now this is already 0, it is given for 0z. And then we have for the positive numbers, we have everything on the positive side and everything on the real side. The imaginary part is all 0 here. So that is for a square root. Similarly for cube root also, so we can make it as cube root here. So this is cube root of ARR1i. So that's how I am going to print this. So I am going to give the cube root of all these numbers, minus 3, minus 2, minus 1, and all this we are getting this cube root here. So you can see this number is minus 3, minus 2 is something as a different number. So I was interested in minus 1, cube root of minus 1. So this is something I am interested in. So this number, you notice carefully what it is. It is 0.5 on the real side and 0.86 on the imaginary side, and the same number is coming here, 0.5 on the real side and 0.86 on the imaginary side. So this is coming from our genuine calculations that we are doing here with all these roots and all, and this is coming directly from the NumPy. So similarly, cube root of any negative numbers can be calculated very simply using this formula and this style. Okay, so that is what I have illustrated. Our NumPy and our Python is already intelligent enough to calculate the cube root of all these numbers effectively, and it can do cube root, nth root of any number, and that will be expressed in terms of real number and imaginary number. Simply, if we think of making cube root instead of cube root, let us think of making Suppose we want to make 13th root. Suppose we want to make 13th root of the entire array. That also we got. Okay. So that also we got, 13th root also we got. So that is quite possible. So in case we want to put 13 13th root, 13th 13th, I am just putting 13th, and then I am putting all this. Thirteenth and print cube roots. 13th. Okay, now you can run this. So that way you can see, for 0 it's okay, for 1 it's okay, for -1 it's like this. So for -1, -2, -3, all these numbers we have roots in terms of I and j, means in terms of real and imaginary number. So for each of this we have things in terms of real and imaginary number. So things can be calculated. So
Lot of things that can be calculated. So we see that we have understood all these things, and we know that a lot of things can be calculated, and there is a lot of a scope in which complex number has got to play a major role in our ever demanding industry. Because so far we are not looking at complex number, because we think that in physics, when light speed of light, something gets a velocity beyond the speed of light, it becomes irrelevant. We do not think about that, and many things becomes something becomes obsolete after getting a negative things under the square root. So this is something we are thinking that we have lost the data there. We don't have ample data, and we cannot do lots of calculation beyond that point. So all these things happen, but there is a lot of scope that we can do. There is a lot of things that we can do beyond our regular imagination, in which we are not considering results when there is something undefined, but that undefined things is still having some information in it, and that can still resemble some kind of calculations in mathematics. And if it is not giving some value today, maybe at some part of time, this imaginary things, this complex things, which is just like bulb, and this is not giving any calculation today, if encounters something, it multiplies with something that where it means something, then it can give some calculation result, and then we will be able to get into a particularly entirely new conclusion. So we will find something different result, and we will have to see how it comes. So I think this complex number calculation is in some way related to our data science also. Just like data science is something which gives lots of mysterious results, some kind of predictions which otherwise we cannot get from normal calculations, similarly complex numbers calculations has got to do. And I think if we put more light on complex number calculations and its involvement in lots of physical activities in the sense of already it is used in electronics, magnetics related theories, and also if we'll get more into that, maybe probably we'll discover more into that. And I put an emphasis on study of complex number beyond limit. Beyond limit means whatever limits we have studied so far, we should go beyond that limit and we can study further on complex numbers in relations to our day-to-day subjects. Okay, so that's all for from my today's session. I am closing the chapter now. We'll discuss in some next lesson next time. Thank you. Bye.